The Space Shuttle was a partially reusable low-Earth orbital spacecraft system operated by the U.S. National Aeronautics and Space Administration. Its official program name was Space Transportation System, taken from a 1969 plan for a system of reusable spacecraft of which it was the only item funded for development. The first of 4 orbital test flights occurred in 1981, leading to operational flights beginning in 1982. They were used on a total of 135 missions from 1981 to 2011, launched from the Kennedy Space Center in Florida. Operational missions launched numerous satellites, interplanetary probes, and the Hubble Space Telescope, conducted science experiments in orbit, and participated in construction and servicing of the International Space Station. The shuttle fleet's total mission time was 1322 days, 19 hours, 21 minutes and 23 seconds. Shuttle components included the orbiter vehicle, a pair of recoverable solid rocket boosters, and the expendable external tank containing liquid hydrogen and liquid oxygen. The shuttle was launched vertically, like a conventional rocket, with the 2 SRBs operating in parallel with the OV's 3 main engines, which were fueled from the ET. The SRBs were jettisoned before the vehicle reached orbit, and the ET was jettisoned just before orbit insertion, which used the orbiter's 2 orbital maneuvering system engines. At the conclusion of the mission, the orbiter fired its OMS to deorbit and re-enter the atmosphere. The orbiter glided to a runway landing on Rogers Dry Lake at Edwards Air Force Base in California or at the shuttle landing facility at the KSC. After the landings at Edwards, the orbiter was flown back to KSC on the shuttle carrier aircraft, a specially modified Boeing 747. The first orbiter, Enterprise, was built for approach and landing tests and had no orbital capability. 4 fully operational orbiters were initially built: Columbia, Challenger, Discovery, and Atlantis. Of these, Challenger and Columbia were destroyed in mission accidents in 1986 and 2003 respectively, in which a total of 14 astronauts were killed. A 5th operational orbiter, Endeavour, was built in 1991 to replace Challenger. The Space Shuttle was retired from service upon the conclusion of Atlantis' final flight on July 21, 2011. Overview. The Space Shuttle was a partially reusable human spaceflight vehicle capable of reaching low Earth orbit. Commissioned and operated by the U.S. National Aeronautics and Space Administration from 1981 to 2011. It resulted from shuttle design studies conducted by NASA and the U.S. Air Force in the 1960s and was first proposed for development as a part of an ambitious second-generation space transportation system of space vehicles to follow the Apollo program in a September 1969 report of a space task group headed by Vice President Spiro Agnew to President Richard Nixon. Nixon's post-Apollo NASA budgeting withdrew support of all system components except the shuttle, to which NASA applied the STS name. The vehicle consisted of a spaceplane for orbit and re-entry, fueled by expendable liquid hydrogen and liquid oxygen tanks, with reusable strap-on solid booster rockets. The first of 4 orbital test flights occurred in 1981, leading to operational flights beginning in 1982, all launched from the Kennedy Space Center, Florida. The system was retired from service in 2011 after 135 missions, with Atlantis making the final launch of the 3-decade shuttle program on July 8, 2011. The program ended after Atlantis landed at the Kennedy Space Center on July 21, 2011. Major missions included launching numerous satellites and interplanetary probes, conducting space science experiments, and servicing and construction of space stations. The first orbiter vehicle, named Enterprise, was built for the initial approach and landing tests phase and lacked engines, heat shielding, and other equipment necessary for orbital flight. A total of 5 operational orbiters were built, and of these, 2 were destroyed in accidents. It was used for orbital space missions by NASA, the U.S. Department of Defense, the European Space Agency, Japan, and Germany. The United States funded shuttle development and operations except for the Spacelab modules used on D1 and D2, sponsored by Germany. SLJ was partially funded by Japan. At launch, it consisted of the stack, including the dark orange external tank, 2 white, slender solid rocket boosters, and the orbiter vehicle, which contained the crew and payload. Some payloads were launched into higher orbits with either of 2 different upper stages developed for the STS. The Space Shuttle was stacked in the vehicle assembly building, and the stack mounted on a mobile launch platform held down by 4 frangible nuts on each SRB, which were detonated at launch. The shuttle stack launched vertically like a conventional rocket. It lifted off under the power of its 2 SRBs and 3 main engines, which were fueled by liquid hydrogen and liquid oxygen from the ET. The Space Shuttle had a 2-stage ascent. The SRBs provided additional thrust during liftoff and first-stage flight. About 2 minutes after liftoff, frangible nuts were fired, releasing the SRBs, which then parachuted into the ocean, to be retrieved by ships for refurbishment and reuse. The orbiter and ET continued to ascend on an increasingly horizontal flight path under power from its main engines. Upon reaching 17,500 miles per hour, necessary for low Earth orbit, the main engines were shut down. The ET, attached by 2 frangible nuts, was then jettisoned to burn up in the atmosphere. After jettisoning the external tank, the orbital maneuvering system engines were used to adjust the orbit. The orbiter carried astronauts and payloads such as satellites or space station parts into low Earth orbit. The Earth's upper atmosphere or thermosphere. Usually, 5 to 7 crew members rode in the orbiter. 2 crew members, the commander and pilot, were sufficient for a minimal flight, as in the first 4 test flights, STS-1 through STS-4. The typical payload capacity was about 50,045 pounds but could be increased depending on the choice of launch configuration. The orbiter carried its payload in a large cargo bay with doors that opened along the length of its top, a feature which made the Space Shuttle unique among spacecraft. This feature made possible the deployment of large satellites such as the Hubble Space Telescope and also the capture and return of large payloads back to Earth. When the orbiter's space mission was complete, it fired its OMS thrusters to drop out of orbit and re-enter the lower atmosphere. During descent, the orbiter passed through different layers of the atmosphere and decelerated from hypersonic speed primarily by aerobraking. In the lower atmosphere and landing phase, it was more like a glider but with reaction control system thrusters and fly-by-wire controlled hydraulically actuated flight surfaces controlling its descent. It landed on a long runway as a conventional aircraft. The aerodynamic shape was a compromise between the demands of radically different speeds and air pressures during re-entry, hypersonic flight, and subsonic atmospheric flight. As a result, the orbiter had a relatively high sink rate at low altitudes, and it transitioned during re-entry from using RCS thrusters at very high altitudes to flight surfaces in the lower atmosphere. Early history. The formal design of what became the Space Shuttle began with the Phase A contract design studies issued in the late 1960s. Conceptualization had begun 2 decades earlier, before the Apollo program of the 1960s. One of the places the concept of a spacecraft returning from space to a horizontal landing originated was within NACA, in 1954, in the form of an aeronautics research experiment later named the X-15. The NACA proposal was submitted by Walter Dornberger. In 1958, the X-15 concept further developed into proposal to launch an X-15 into space, and another X-series spaceplane proposal, named X-20 Dinosaur, as well as variety of aerospace plane concepts and studies. Neil Armstrong was selected to pilot both the X-15 and the X-20. Though the X-20 was not built, another spaceplane similar to the X-20 was built several years later and delivered to NASA in January 1966, called the HL-10. In the mid-1960s, the U.S. Air Force conducted classified studies on next-generation space transportation systems and concluded that semi-reusable designs were the cheapest choice. It proposed a development program with an immediate start on the Class 1 vehicle with expendable boosters, followed by slower development of a Class 2 semi-reusable design and possible Class 3 fully reusable design later. In 1967, George Mueller held a one-day symposium at NASA headquarters to study the options. 80 people attended and presented a wide variety of designs, including earlier U.S. Air Force designs such as the X-20 Dinosaur. In 1968, NASA officially began work on what was then known as the Integrated Launch and Re-entry Vehicle. At the same time, NASA held a separate Space Shuttle main engine competition. NASA offices in Houston and Huntsville jointly issued a request for proposal for ILRV studies to design a spacecraft that could deliver a payload to orbit but also re-enter the atmosphere and fly back to Earth. For example, one of the responses was for a two-stage design, featuring a large booster and a small orbiter, called the DC-3, one of several Phase A shuttle designs. After the aforementioned Phase A studies, B, C, and D phases progressively evaluated in-depth designs, up to 1972. In the final design, the bottom stage was recoverable solid rocket boosters, and the top stage used an expendable external tank. In 1969, President Richard Nixon decided to support proceeding with Space Shuttle development. A series of development programs and analysis refined the basic design, prior to full development and testing. In August 1973, the X-24B proved that an unpowered spaceplane could re-enter Earth's atmosphere for a horizontal landing. Across the Atlantic, European ministers met in Belgium in 1973 to authorize Western Europe's manned orbital project and its main contribution to Space Shuttle, the Space Lab program. Space Lab would provide a multidisciplinary orbital space laboratory and additional space equipment for the shuttle.